Oh, hi. This is a real school website. It's a public, anyone can pull it up. And it does 5 things almost every school in this country does. New staff directory, a phone gallery, a PDF of the bell schedule, and a timetable. Typical, basic, functional. But under the hood is carry some heavy constraint. So this gallery alone has 40 GB of photo and an event video that almost nobody opens after a first month. And behind those 60 staff members are 800 students, with the whole site usually maintained by one teacher during a spare period. Because there's no dedicated IT department to call, I'm going to rebuild this entire site on AWS as a proper production-grade architecture. Under $20 a month, costs 6 episodes. Real infrastructure as a code, no console clicking. And I'm adding one feature this site never get right: the parent-teacher interview bookings. Every school I look at handle this with the paper slips or Google Sheet someone has to undoubted book by hand. We are building a real system for it. And because losing a booking actually matters, that is one part of this system that gets a real database in episode 4. And here's the rule for this entire series. We destroy everything we build. Every live AWS resources created in an episode get torn down and verified live at the end of the video. So it's gonna be 0 leftover infrastructure, 0 surprise build running in the background. And then one final note, I'm not touching their live site. I'm building this for a simulated school with the exact same constraint. No student data, 0 consequences, and everything stay in Canada in CA Central 1. So let's look at the first state, the storage. So starting with the storage, I'm using 2 S3 bucket here instead of 1 because they have completely opposite lifecycle. The website bucket holds our HTML and static assets. It's a tiny few megabytes and it's getting read constantly. The media bucket holds 40 GB of photo, video, and PDF. Almost nobody touch after the first month. If you shove both into a single bucket, you're forced to apply one lifecycle policy to everything. And there is no single policy that makes sense for both. Let's look at the bucket TF file. First, the versioning is turned on, and that is our entire backup strategy. Nobody at school is ever going to write a backup cron job or manage snapshots. Either S3 retain its own history or there are no history. So now down to the line 45. I'm setting the BucketOwnerEnforced to turn off the ACL completely. IAM policy alone decide who gets in. That gives us a one place to reason about permission instead of 2 conflicting systems fighting each other at 3 o'clock in the morning. In the module, static site, and let's look at the variable. Now line 71 is when I got caught out. I originally had a force destroy set to 4 on principle. A Terraform destroy shouldn't be able to accidentally wipe out a photo, video, PDF archive. But when I destroy a test stack down by hand and discover that what versioning actually does to you, when you run the AWS S3 RM recursive on a versioning bucket, AWS doesn't actually delete the file, delete marker over every object key. So AWS 3 LS show a clean, beautifully empty bucket, but the delete bucket keep failing because every old version and delete marker is still sitting right underneath it. In my case, there are 5 hidden versions sitting in the site bucket blocking the teardown. So for this repo, the honest default for force destroy is true because our workflow is apply, test, destroy. But for anything holding real product photos, PDF, you want it false. That's why it exposes as a variable with the whole backstory written directly in the description. So nobody has to guess why it's there. Next up. This single bucket holds 2 completely different lives, photos and event video under photo/folder and video/folder, which grow quickly and get read almost never after the first month, plus the school document under the doc folder. That's are small. but downloaded all year. So the code link step down, standard for the 30 days, and the IA for the 60 more. Then Glacier instant retrieval. And I want to be specific about which Glacier because these are two and picking the wrong one doesn't meet the requirement. Glacier flexible is the cheap one. It's also not readable. A get object on an archive object doesn't come back slowly. It fell. You have to fire a restore job. Wait 3 to 5 hours and then you can read it. And nothing in this static system know how to do that. There's no restore code, no worker queue, no check back later page. So the day this school does put a gallery here, a parent click last year content like photo and probably gonna get the broken image. And you probably find it out not today, not on the upload, 90 days after the upload. So when the object finally transition, this is the decision that has to be right before this is anything to test with it. Now, instant retrieval read in milliseconds, same call, same speed as the standard. And the differences in storage cost between the two, was 40 GB of media, is about 2 cents a month. Now let's go back to this bucket.ts file. Let's look at this block of code. The IR at the end of standard for the instant retrieval. I put a big comment and explain this specifically. No, well, in S3, Glacier file take hour to restore. You are going to break the website. I would think that Glacier IR is a typo or an alias and try to clean it up. But Glacier IR is a complete different storage class. It gives you the closed storage pricing while millisecond HTTP access. So the website keep working. Now look at the doc folder for the PDF. We actually never want to move to the closed storage. Moving the PDF to Glacier would be backward because the parent download them all years. And Glacier charge a fee every time the file is downloaded. To be completely honest with you, all these fancy cold storage rule apply to photo and video, which we are not even sorting yet. Right now, this sites only have 2 GB of PDF, which is called 4 cents a month in a standard storage anyway. But I build the rule now so that when they do upload photo archive later, the bucket handle is automatically without blowing up the bills. Now look at the video and photo. We actually have a filter rule on that one, but we never roll a rule for the PDF, right? So see this filter empty here. So AWS doesn't have an everything except doc filter. So anything outside those two folders just stay in the standard storage. That is the safe path to set it up. Now both of these S3 buckets are completely private, not public with a bucket policy that block it. Actually private. Look at this dash arrow along the bottom, pointing directly at the bucket. That request failed every single time. CloudFront is the only way in. Starting in this block, we define our original access control, OAC. OAC works by signing every single request from the CloudFront to S3 using the AWS signature version 4. If you work with AWS for a while, you probably remember OAI, the original access identity. You will still see OAI in half of the tutorial online, and it still works, but the OAC is the modern replacement you should be using now. Now look at 162 line. This is the bucket policy that complete the handoff. The bucket policy trusts exactly one principle, but there's a critical detail on 175. Use a source ARM condition typed directly to this specific CloudFront distribution. Not CloudFront in general, not just any distribution in my AWS account, only this distribution. If anyone else try to point their own CloudFront distribution at your bucket, S3 just reject the instant. Another interesting point we can look at is this block of the code. So we are mapping each real prefix explicitly. There's no /media catch-all. That's because the CloudFront does not strip the prefix before sending the request to S3. If the browser asks the CloudFront for like media, then photo.jpg, CloudFront ask S3 for media photo.jpg, not photo.jpg. Okay, so there's no setting to change that behavior. And I actually learned that the hard way. So I will show you how that caught me out in a future video. And just like the S3, two of those three behavior pointing to the prefix, nothing right to yet. They're generated in a for each loop, the line here. So carrying the item away now costs $0. This line we set the price class when you click on it. So this restricts the CloudFront edge location to North America and Europe. The users for this site are at one school in Canada, paying extra to cache static website at the edge location in Asia. So nobody in Asia is gonna look up this site. And here I especially made a comment to that. We don't need any access log bucket, because access log would means running a second S3 bucket, accumulating the storage fee to answer access question that nobody at this school will ever ask. So I left the comment there on purpose, so if anyone reading the code knows it was intentional decision, not an oversight. So there's another point that I want to make in this block of code. Why do we need this? Because this handles a single page app routing. If someone visits a page like, say for example, /about, S3 does not find a file and send back a 403 forbidden error. We tell the CloudFront to catch those 403 and serve index.html instead. So React can load the page properly, and the only downside is if an image link is actually broken, S3 serves index.html instead of giving you a normal 404, which makes broken link a bit trickier to spot when debugging. So there's a trade-off. Now is the payoff time. Let's spin up all the resources and see how the live website is going to be look like. I will actually jump into the storage folder. So I'm gonna do the Terraform init first. The next command I'm gonna do is Terraform plan. So it looks okay to me. Now we can do Terraform apply. While the CloudFront build in the background, let's address something that you probably noticed. There's a no remote backend here, no S3 bucket, and no DynamoDB state lock. While the CloudFront builds in the background, let's address something that you probably noticed. There's a no remote backend here, no S3 bucket, no DynamoDB state log. Every Terraform tutorial tells you that you need to set up a remote state on day one, but the remote state exists to keep a team from stepping on each other's toes, right? So if it's just you, which is my case, so there's no team collusion. So I'm gonna skipping that. It also avoid that classic chicken and eggs headache. So you need another like S3 bucket to store those state file. So I don't need another S3 bucket to store the state file. Plus, keeping the states local to each directory give you the natural isolation. Stage 1 literally cannot touch or mess up the stage 2. Okay, we're done. The CloudFront is live. So let's go into the AWS console and see what happened. Now, this is our CloudFront. So basically it's going to pointing to these two different S3 bucket. And when you look in the behavior, we are going to have like docs for PDF, photo, and video. And we cover 403 and 404 error page as well. Now, also, let's look at the S3 bucket. I'm gonna pick the school media. So when you look at this S3 bucket, the block public access is fully turned on and the ACL are disabled. If you go down and check the bucket policy, that's our CloudFront OAC policy. So it is restricting access strictly to our distribution ARM here. We can actually copy this distribution domain. Voila! Our website is actually live. We don't have anything that is functional right now because as we're building this project, those functionalities going to be show up. Right now, we just only have 2 buckets and also a CloudFront distribution. So now for the final rule of this entire series, we are going to destroy everything we just built live on the camera. So let's run the Terraform destroy and say yes. Now while this is working, let's talk about the build. So the baseline cost for what we built today is effectively $0, a month at rest. So S3 only charge for storages and our bucket are empty. CloudFront free tier easily cover the bandwidth for the single school site. And there's no compute running in this episode at all. And to be honest, those lifecycle rules that we wrote don't save us a single cent today. They don't kick in until the object age past 30 days, which is require real traffic in real time. Also, every resources in this stack is tagged with project equals school. So in episode 6, I will show you why that tag alone is not enough to get a cost report you can actually read. There you have it. See you for the next episode.